Authentication tells us who is connecting. Authorization decides what they can do. In AI workloads, that means giving users, agents, APIs, models, and data stores only the access they truly need, while still allowing teams to innovate. We've already covered the AI security architecture, risk priorities, and authentication foundations like SSO, MFA, and conditional access. Now we move from proving identity to controlling exactly what each identity can do. That sets up the next topic: secrets and privileged access. Once identity is known, authorization decides what that identity is allowed to do, right now, against a specific resource. In AI workloads, that decision has to follow every path: users, apps, API clients, model endpoints, retrieval systems, tools, and agents. Strong policies consider identity, action, context, and risk. Least privilege matters because one over-permissioned token or agent can expose documents, prompts, tool access, or generated outputs. In AI architecture, identity is not just a person logging in. Every actor that requests data, calls a tool, runs a workflow, or triggers a model needs an identity. That includes employees and admins, but also APIs, services, CI/CD jobs, cloud workloads, managed identities, agents, orchestrators, and RAG components. The mental model is simple. If something can take action, it must be authenticated, authorized, monitored, and governed as an identity. Choose the authorization model based on how specific the decision needs to be. RBAC works well for broad roles like admins or standard users. AI workloads often need more context. ABAC checks attributes such as department, tenant, region, device posture, and data sensitivity. ReBAC adds relationships, like document owner or project member. For RAG and sensitive documents, combine these approaches with centralized policy engines so decisions stay consistent and auditable. Least privilege is an operating loop, not a checkbox. Start by discovering every identity, dataset, model endpoint, vector index, API, and tool integration the workload can touch. Then classify what each asset is used for and map the exact actions required, such as retrieve, generate, update, export, or administer. Begin with deny by default, then add only the permissions needed. Finally, validate access and keep reviewing logs, analytics, and entitlements as the system changes. Instead of giving every pipeline, pod, or service a long-lived key, let the runtime prove who it is. Federation connects that proof to Cloud IAM, so a Kubernetes service account or CI job can exchange its identity for a short-lived token. Access can then be tied to attributes like namespace, cluster, deployment, and workload purpose. If one component is compromised, narrow permissions and expiring credentials limit blast radius and reduce lateral movement. Model endpoints should be treated as protected business assets, not just another API. Authorization should combine who is calling, which application and tenant they represent, and the risk of the request. Then grant specific operations, because inference is different from fine-tuning, deployment, evaluation, or administration. A gateway helps enforce this by checking policy, applying quotas and cost limits, routing only to approved models, and recording audit evidence for security, billing, and compliance. In RAG, authorization is not just about who can ask a question. It is about which sources the system is allowed to use when answering. If documents enter the vector index without permission metadata, similarity search can quietly cross boundaries. The model may summarize restricted content even if the user never saw the document. Treat the pipeline like a secure library. Check permissions during indexing, enforce them during retrieval, and validate evidence before generating the response. Document authorization starts before anything is embedded. As content is ingested from systems like SharePoint, Confluence, Drive, or a data lake, the pipeline must capture source ACLs, owner, tenant, sensitivity, and classification. Those attributes should stay attached to every chunk and vector record. At query time, retrieval is filtered using the caller's identity. If permissions change upstream, the index must be refreshed so old access rules do not keep leaking results. Semantic similarity is not an authorization model. A vector search may find the right meaning in the wrong tenant, project, or classification. The query needs to carry identity context into retrieval. Build policy filters from the user, group, tenant, and project. Then apply them inside the vector database search using namespaces, partitions, or metadata constraints. Finally, validate every returned chunk before prompt assembly. Unauthorized chunks should be blocked, not merely ignored after they reach the model. Treat every token as a temporary key to enterprise data. OAuth or cloud tokens should name the right audience, issuer, tenant, resource, scope, and allowed operations. Avoid shortcuts like full mailbox, full drive, data lake, or admin access. When AI acts for a person, prefer delegated access. Use application permissions only for justified services. Separate tokens for retrieval, model calls, administration, and background jobs, so one compromise stays contained. Authorization is not a one-time decision. It has to live with the session. For AI systems, keep access tokens short, especially for admin changes, exports, and deployments. Treat refresh tokens like high-value secrets, tied to device health, conditional access, and secure storage. When risk changes, revoke the session immediately, such as after role changes, project removal, compliance failure, or suspicious signals. For sensitive actions, require step-up authentication, so stronger proof is needed before higher-impact AI access. Consider a support agent that can look up a customer, summarize tickets, and draft a response. It should not inherit a manager's full access. Give the agent its own identity, then limit each tool by action, data type, and customer context. Routine reads may proceed automatically. Refunds, deletions, privilege changes, or outbound messages should pause for approval. Every decision, tool call, input, output, and allow or deny result must be logged for review. The core message is simple. AI authorization must be precise, contextual, and auditable across every identity, document, model endpoint, API, tool, vector query, and agent action. Enforce least privilege everywhere, especially in RAG and autonomous workflows. Next, we secure the secrets that make privileged access possible with HashiCorp Vault.